In this video, we are going to code a very special token. This token automatically gives reward to its holders without requiring to stake the tokens anywhere. And that's great to make your token very attractive for investors. If you don't know me, I'm Julian, and on Eat the Blocks, I teach blockchain development. To create our token, we will use a Solidity smart contract provided by the Yield protocol. The Yield protocol is a DeFi protocol to borrow or lend a token against a fixed rate. So I'm not going to detail how the Yield protocol works, but we are only interested in one of their library. So the GitHub organization is Yield protocol, and the repo that we're interested in is Yield Utils v2. And the contract we want is in contracts token ERC20 rewards. All right, so let's scroll down. So here we have a couple of import, but these are low level stuff, so we can skip them. And here, this is a definition of our smart contract. And here our smart contract start. And here we scroll down. And so these struct here are important. So here in this struct, we are going to store the period of the reward program. So this is a standard ERC20, but on top of it, you can define a reward period. And during this reward, anybody who is a holder will receive some reward. And start and end are two timestamps. Then in another struct, we store all the details about the reward program. So first, how much reward token. So here accumulated, this is how much reward token you would have accumulated if you had a balance of 1 token since the beginning of the reward program. Then the last time we updated this struct. And here, what's the reward per second per token. And after, we have a struct to store some info about the reward specific to each user. And this will allow to know exactly how much reward we need to send to the user. So here we just define this struct, but below we instantiate them. And we also instantiate a mapping here. So for each holder, it's going to map to a user reward. And after, we have the constructors. So we have some standard field for ERC20, name, symbol, number of decimals. And we also pass the address of the rewards token. So this is supposed to be another token. Okay, so let's scroll down. After, we have the set rewards function. So that's going to be access controls. So an admin is going to call this function to set a new reward program with a different parameter. Start date, end date. So this is a timestamps in second, and rate, how many reward you distribute per second for 1 token. So after, we have a few sanity check. And we store the details of the reward program. After, let's scroll down. So let's skip this. We're going to come back to it after. So here we have a function to, if you want to mint. If you don't want your token to be mintable, you can just comment it out. Then another function for burning. So that's the same thing. You can comment it out. Then you have a transfer function to transfer token from an address to another one. And finally, a claim function. We'll see this one at the end. That's to claim your reward. So here, what's interesting is that in the mint, burn, and transfer function, every time we call the same function, update rewards per token, update user reward. Okay, so first, let's check out update rewards per token. So this is going to update this struct rewards per token. And this struct has an accumulator that tells us how much reward token have accumulated since the beginning of the reward program. So here we copy in memory the 2 struct, rewards per token and reward period. If the reward program hasn't started yet, we just skip this function. Here we find the earliest time between the current timestamp and the end of the reward program, because maybe we're after the end of the reward program. Here we calculate the time elapsed since the last time that we updated the accumulator. And of course, if this is 0, then we can skip. And below, that's where we are going to update the accumulator. And so here we multiply the unaccounted time by the rate. And after, we update the rewards per token struct. And with this, we are ready to calculate the reward for the user. So here we have another function for this, update user reward. And so first, we copy in memory the reward struct for the specific user, also rewards per token that we just updated. And after here, we are going to calculate how much reward have accumulated since the last time that we've run this calculation. So here, if there's any leftover undistributed, we add it. And after, we are going to calculate the reward. So we take into consideration the balance of the user. And we multiply this by rewards per token accumulated. So here this quantity is per token. So that's why we can multiply it. But we subtract checkpoint. So checkpoint, this is everything that we have already distributed to the user in the past. And we divide this by 10 power 18 because these two quantities are scaled by this. Okay, and after we save the updated info on the reward for the specific user and we return this, so that's how much reward we need to give to the user. And so after, let's go back to the bottom function claim. To get reward, a user needs to call this function. So you can send your reward to another address, but you don't have to. And so first we are going to call update rewards per token, then update user rewards, and claiming here, so this is the amount of reward that we are entitled. So we reset the accumulated field for the specific user to avoid giving twice the reward. And after, we transfer the reward to the user with this line. So here you see that we call the save transfer function. So the reward token doesn't need to have this function because above, let's see, above we use this line using minimal transfer helper. So basically we're going to attach a library to any ERC token in this contract, and it's going to add some new function like save transfer. So your token just need to implement the standard interface of ERC. You can just ignore this save transfer thing. But here, one very important thing to note is that this transfer is going to be done from the address of your token to the address of the user. So that means that before you start your reward program, you need to send some reward token to this token. Otherwise, the transfer function is going to fail. Okay, so that's it for this smart contract. It has 20 rewards. Next, I'm going to show you how you can use this smart contract to create your own token. So now I'm going to show you how you can create your own reward token. So this is the repo of Eat the Blocks, and this is the folder for these tutorials. This is a truffle project. And here we're going to go in the contracts folder. So in yield utils v2, I basically copied over all the contracts folder of the yield utils v2 repo. So here we can find in token ERC20 reward as well as all the other contract. Our reward token here, this is token.sol. So this is very simple. First we import ERC20 rewards, then we define a contract we inherit from it, and in our constructor we receive an argument, so that's the address of the reward token, that's another token, and we call the constructor of ERC20 rewards, and we pass the different parameter of our token as well as the address of the reward token, and also mint some token to the sender. So this is just for testing. And after, in contracts, I've just defined another ERC20 token, and so that's just for testing, and that's the token that will be given as a reward. And just like this, you can create a token with a built-in reward feature. So now you know how to create a token with a built-in reward mechanism. At the time of recording this video, this is still very new, but I think it will rapidly become more popular because it's a better user experience for investors who don't need to manually stake their tokens. Next, if you want to keep learning advanced topics about token, you can check out this video where I explain how you can set the price of a token on liquidity pools like Uniswap or PancakeSwap. I will see you there.